So the next step is calculate the correlation and R-squared, the coefficient determination or the proportion of variation, and say what they mean. So I'm seeing a positive slope on my regression equation, so that tells me the correlation will also be positive. I see R-squared, so all I really got to do is take the square root of R-squared, make it a decimal. This is already a decimal, so I don't have to worry about that. So on this calculator, I can just do second square root and type in 0.495 and the square root. So there's the correlation, the 0.703. What does that tell us? There's a moderately strong association, linear association between per capita sales of cigarettes and the death rate for bladder cancer. And so that's all that means. Now the R-squared is a more interesting number. If you change this to a percentage, that's going to give me 49. Here, let me go something not quite so big. That's going to tell me 49.5%. And what that tells me is 49.5% of the variation in cancer deaths can be explained by an increase in the sales or a change in the sales of cigarettes. And that means a little better than 51% of the change or the variation is explained by some measure we don't know, some lurking variable, some other thing. So, you know, it's not a perfect relationship by any sense of the imagination. And that's all you have to talk about that. That's so percent of variation, coefficient determination, R-squared, all the same number, all the same, three different things that mean the same thing. And it's the percent of change or the percent of variation in the cancer deaths or the Y variable that can be explained by changing the X variable, of the explanatory variable. And that's that.